Hello everyone. So I hope you all are working hard towards your dream. So the problem which we will solve today is the longest almost palindromic substring, right? So I have sorry for the late solution. First of all, the reason for the late solution is because I was not able to have a work on the video, so that's the reason for being late. Let's quickly jump into the solution. So you're given a string S consisting of lowercase English letters. A substring S is almost palindromic if it becomes a palindrome after removing exactly one character from it, right? And we need to return an integer denoting the length of the longest almost palindromic substring in S, right? So let's take a test case ABCA, right? So I have already made some tasks for you, right? You will understand this, right? So let's take this test case ABCA, right? And what is the problem statement? The problem says that you can remove any one character from the substring that you are choosing, right? You can choose any substring, right? Let's say you took up this substring, and from this you can delete any character of your choice, right? So substring, let's say it was ABC, right? And now you can delete any character, and if it is a palindrome, then we will say it is an almost palindrome, right? So the structure for almost palindrome must be clear, that almost palindrome is when you surely need to delete one element, right? One element must be deleted from any substring that you have chosen, right? All right. So in this test case, what we can see is, let's say A, B, C, A, right? Now from this, if you, let's say, you took up this whole substring A, B, C, A and delete this C, right? Or let's say you delete this B, you can do any of your choice. Then the substring which will be left to you will be ABA, right? And this is a palindrome because A is equal to A and B is equal to B, right? I hope you know how to solve a palindrome. If not, let's say race car is an palindrome. Why? Let me show it. So R, from the reverse, like first element is equal to the last element, second element second last element, third element third last element, and fourth last element with 4. So this is how a palindrome works, right? So if you reverse this thing, it will still be race car. C R A C E C A R, right? So I hope the condition or the logic for palindrome is clear to you, right? And I hope if you are solving the third problem for the contest, so it might be a bit obvious that you should know that what is a palindrome, right? All right. Wait a second. Yes. So let's take one more test case. Let's say ABBA, right? So if you look at this test case ABBA, right? ABBA, right? So if you look at this test case now, what they are saying that you can delete any string character A or B and still you will left with ABA, and you can see this is a palindrome as well, right? And moreover AB and BB, the whole substring initially was also a palindrome, right? So this is the, I hope the problem statement is clear to you, right? So let's look at the constraints, that so that we can generalize or come to a solution, what solution needs to be done, right? So if you look at the constraints given to us is 2500, right? So it is 10 to the power 3, right? 2500 is like 2000, right? So you can write a solution which will take big O of n square time and it will still be accepted, right? So we need to somehow manage the solution or write a code which can run in big O of n square, right? So if you think, then we should generate all the substrings, right? We should generate all the substrings like A, AB, then AB, B, and then AB, BA, right? Similarly, B, then BB, and BBA, and then all the substrings which could be formed, right? For an n-length string, big of n square substrings can be formed, right? So we need to create all those substrings first of all, right? This is, I think, this should come to your mind that this needs to be created, right? So after we create this, what can be done, right? So now after when we create this substring, there comes an interesting topic of dynamic programming, right? Of DP, right? I have seen many YouTubers, or you can say solutions, which were like expanding around the corner or something like that, right? I found that topic to be very, like, not I found didn't found that very much easy, right? So DP will be very much easy to you, right? Now why DP will be easy is we will solve this problem using another concept of DP. Let me type that, right? That concept is known as minimum. I think I can, if I will be able to increase, yes, not this much, yes. So this is alright. So minimum deletion to make a string, a palindrome, right? Palindrome, right? Now this is the problem statement, right? If I say you how many strings need to be deleted to make a string palindrome, right? You need to find the minimum deletions to make a string palindrome, right? What do you think will be the time complexity to solve this problem, right? If you don't know, right, let's say we had a string a, b, let's say c, and let's say a, right? So in this, right, let's say we were on a, right? So is what the logic of this problem statement is, let's first understand that, right? So the logic for this problem is, if we the two elements are same, like a, right, then our solve function will simply move solve. Let's say solve was there, right? And solve, what its solve was doing was solve of I plus 1. Let's say this was I, right? And let's say this was j, right? So I plus 1 and j minus 1, right? Because the both elements have matched, you don't need to delete any character, right? A man with sensibility will never delete two strings or two characters if they are already same, right? Now when we went to b, right, and this character will move back, so now we are on b, c, right? And they both are not same, right? Are they same? No, they aren't same. So you have two options, right? Either you can move this pointer, you can say I will delete this character, or you can say I can delete this character, right? See, there might be different cases, like you need to imagine this thing, like if you had a b, right, and let's say you deleted this b, but not deleting this b would have been beneficial to you. Let me show how. Let's say I had a, b, right? Let's say a and c. This is the case where you thought, okay, I should delete this b, right? Let's say you deleted this b. Then what will happen now? Let's say you had still a b and all b were here only, right? Just for in case, right? So if you have might have deleted this c, then this b and this b would have matched, right? And if you haven't deleted, if you have deleted this b, then it becomes, let's say it was deleted, right? So then three b's will be there, so a, b, 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 c, a. Now also this c isn't matching with this b, right? So you never know what the substring or what the string or what the characters will be in front in the future, right? So there will be every time there will be two opportunities to you, right? What are the two opportunities? The two opportunities is nothing but I can solve either delete this b, right? Deleting this, let me wait. I think my mouse is again making some problems. No worries. Let's say I had a, b, right, and c, a, right? This was what we were discussing. So let's say I was on this character and j was on this character, right? Now what I'm trying to convey you is, when you thought of deleting this b, then what you will do? Your solve function will move. Your solve will, let's say sol ve solve will simply do I plus 1, right? But j remains at the same place, right? Let's call it right move, right? Because you have moved towards your right, right? And let's say left move, right? Left move means you will move towards the left, right? So solve of I comma j minus 1. Why? Because I will remain at the same place, b will this will be storing that index only, but this jth character will move to this point, right? So via this move we can find right and left, and ultimately we will return minimum of left comma right. Are you understanding this? What are we trying to do, right? You will always have two options, and after from those two options you can choose any one of them, and that will give you the return minimum of, I have not written minimum of left comma right, right? All right. So how does this thing solve our problem statement? You might be asking this, right? No worries. Let's say your function returned a value which was, let's say 2, right? Minimum characters that need to be deleted to make that substring a palindrome, or a string a palindrome. Let's say it gave 2. then we will not consider this. Let's say it gave 3, we will not consider this. Let's say it gave 1e9, 1e5, we won't consider this. So what can we consider? We can consider either 0 or a 1. Now you might think, how? Because see, the problem itself said that you need to delete exactly one character. So 1 makes sense. Yeah, deleting one character definitely makes sense. But why 0? Right? Let's say you had a palindromic substring A, B, 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 again a B and a A, right? So this is a palindrome, right? This is a palindrome. Now you need to tell me that why 0 is valid, right? Now when you look closely to this now, if you, let's say you deleted this character, right? You deleted this character, right? Now the string becomes A triple B A triple B A. If you look closely, it is still a palindrome, right? Now you might think, right, because it was an even length and now it became odd, so there might be a possibility that it was a palindrome. So let's check up this element and let's delete this B, right? So A B B A, is that what it becomes? And still it is a palindrome. See, so that's what I'm saying, that if a string is already a palindrome, right, then it will return 0, right? So what we can say is, even if our answer is 0 or 1, we can say it is a valid palindrome. It is an almost palindrome, rather. It is an almost palindrome, right? So I hope this thing is clear to you. So the problem boils down to only this part, that you need to, your function will give you an answer, right? And from that answer, if your answer is less than equal to 1, right, then you can say, right, that this substring is valid, right? This substring is valid, right? And if it is greater than 2, then you won't care also, right? And one more thing, right, if your substring was just a character A, right, then this is already not valid, because you need to delete a character, and after deleting any one character, the value will be 0, so you won't consider this as an answer, right? So I hope this part is also clear, right? Now if you know, right, our solve function will have something like I, J and S, right? Now the most of my friends got this doubt, right? Like they were saying that, okay, you created this solve function, right? It will have a right and a left, right? Now how can you say this function, you will say that this takes a big of n square time complexity, right? This you might come to your mind, right? And you are already saying that you need to generate, I need to generate all substrings, right? This is what I have also said, generate all substrings. So that will also take big of n square, right? So ultimately, after generating the substrings, if we are calling this solve function again and again, then shouldn't it be big of n k power 4? This might come to your mind, right? No, that's not the case, right? That's not how DP works, right? Because when you will solve DP of, let's say, 0 comma 1, or let's say DP of 2 comma 2, right? So when you will try to find these values, you will ultimately store the values which are needed. Let's say DP of 2 comma 2 needed DP of, let's say, 1 comma 2 0. For a second, just imagine this, right? So you will have, you might already have found this DP of 1 comma 0. So to fetch that value, it is taking big of 1 only, not big of n, right? And while you are solving any problem, right, this gets added to your DP states, right? So you will ultimately calculate the whole DP in one time only, right? And to fetch that value, I said it will be big of 1. So DP value will be created, but it is only big of n square, and that is only for creating the substrings which were there. Alright, so I hope the time complexity is clear to you. If you don't know how we said that the time is n square, so there are two changing variables in our solve functions. If there might be a case where you wouldn't have understand that why this is n square. So there are two valid indices I and j, and these two values can go up till n. So that is the reason we were initially fighting for the value that is it big of n square or not. But I think you might have understood that why it is not a big of n square, right? So this is how the problem statement works, right? And we just need to create a solve function that will give us a value of how many deletions required, minimum deletion is required, and after finding that value, if that value is less than equal to 1, right, then we can say, okay, this is a valid string, right? So the problem is easy, right? I hope it is easy. Let's look at a few tests which I have drawn for you. Let's say ABA. So I hope the answer is clear to you, right? answer might be clear to you. That answer will be 3. ABA is a palindrome in itself, so we don't need to delete any character to make it a almost palindrome, because you can delete this B and still you will have a AA, which is a palindrome, right? Alright, so if we look at this, you can see how the flow is. The strings will be 0 1 0 0 0 1 0 2, then 1 1 1 2, and then 2 2, right? So when you have this character A, right, it will be our base case. A cannot be just a substring, so you will return a 0, right? And then you can pause and look at this. I have created for you, the chart for you, so that you can understand. Do a dry run, and even if you get stuck at any point, the picture will be with you, right? So let me zoom it out. If you have any doubt, you can ask. I will definitely try to clear that in the comments, right? So pause it, look at it, and try to draw this tree from your side, because it is very important for you, right? All right, so let's look at the solution for this video, right? So we are running from 0 to n, right? J is also running from I to n, right? So we are creating all the substrings which are needed, right? And if the length is greater than or equal to 2, length should be 2, right? And the solve function is less than or equal to 1, then what we can say, the length is j minus I plus 1, right? I hope this is clear. Like, if you are at this index and your j is there, so I comma j, so it will be 0 1 2 3, right? So ultimately length is 3 minus 0 plus 1, right? And it is 4, right? So length is calculated, and ABCA, you can see the length is 4 only, right? So length we will calculate, and if this value is less than or equal to 1, we will simply store it in our answer and we will return the answer, right? Now let's look at the solve function, right? How this solve function works, as I told you earlier, right? So how it will work, right? If I is greater than or equal to j, right? If you have already passed the thing, right? Let me scroll it down. Let's say you had a string, right? You had a string A, B, C, A, B, A only, right? If you are at this index, if these two values match, you move it. If you are at this point, I is equal to j, and now you can say return a 0, right? Because if you had already reached this point, there is no scope of going forward, right? If dp of ij is not equal to -1, you should return it. If s of I is equal to s of j, what you can say, return dp of ij equal to solve I plus 1. If these two matches, you won't delete any of the character, right? So you will say, okay, move to the next one, you move to the previous one, right? So I becomes I plus 1, j becomes j minus 1. I hope this is clear, right? Int left, how do we move left? So int left means if you have not matched this character, let's say A, B, C, A, right? You were I at this, j at this point, right? So these two haven't matched. So moving left character means simply, let me see it, yes. So left means we will move this jth index forward. So we will say I plus 1. Variables name, you can say, name it anything, right? And for the right one, what we can do, we can do j minus 1 and return minimum of left comma right? And if you submit it, it will get accepted as well. I hope the problem statement is clear to you. If you have any doubt in this, please do ask in the comments. I will definitely try to make you understand that. And if you have doubt in DP, you can ask. I will be more than grateful to make you understand that as well. So I hope the solution was clear to you. Please like and subscribe if it was. Thanks for watching.